Sarbashis Kumar. Today I am showing to find out some theorem of school geometry. Let's see. First theorem, the area of a triangle is half the area of the rectangle on the same base having same altitude. If this is the triangle and this is the rectangle, this altitude is same and base is same, then the area of the triangle is half of the rectangle. Now draw a perpendicular from here. So this is one rectangle and this is another rectangle. From this draw a perpendicular and produce it. So this is one rectangle and this is also another rectangle. Now this is the bisectors and so the area of the triangle ABF equal to half of AFBD. In this is the bisectors, this is the diagonal, not bisector, diagonal. So this is diagonal. So this triangle, this total triangle is half of this rectangle. Again from this is diagonal. So AFC is equal to half of this rectangle. From here this rectangle, this is diagonal, so this area is half of this. Now if we adding the two rectangle, we get total rectangle, and if we get two triangle, we get total triangle. Here if we deduct this triangle from this triangle, and if we deduct total by total, we get same. So the area of the triangle is equal to half of DBC. Let ABC be the triangle and BDC a rectangle on the same base BC and with same altitude AF. It is required to prove that the triangle ABC equal to half of rectangle BDC. Prove since AF is perpendicular to BC, hence BFAD is a rectangle. AB bisect the rectangle, hence ABF equal to half of this. Similarly AF equal to half of this. If we adding this, we get this. If we deduct this, we get this. Hence the complete proof. Now now second proof, the triangles on the same base between the same parallel, hence the same altitude are equal in area. Means this triangle, suppose ABC GBF same base, okay, same base, ABC same base BC, and between the same parallel BC and AG, then these two triangle is equal. It means ABC is equal to BGC. Okay, these are this parallel draw a BCD rectangle. Suppose BC ED is a rectangle. Draw a rectangle. Since ABC equal to ABC and this rectangle has same base and same parallel line, so ABC equal to half of this rectangle, and BGC is equal to half of same rectangle, as because they have same base and same parallel, and that's why these two triangle is equal. Okay, now I read that if BCD is a rectangle on BC and between the same parallels as the given triangles, then ABC is equal to half of rectangle BCED, and also GBC is equal to half of rectangle, hence this. Our third proof is if two triangles are equal in area and stands on same base on the same side of it, they are between the same parallels. It means if ABC and GBC, two triangle, same base and same altitude, and same area, ABC and GBC same area, then prove that if we join the vertex of these two triangle, then AG is parallel to BC. Now draw two perpendicular. Okay, since ABC and GCB area same, so half into base into height, half into BC, hence AFGH is equal, AF and GH is equal. Again AF and GH are perpendicular, it means both are parallel and equal, hence it is a parallelogram. AGHF is a parallelogram, hence AG is equal to FBC. Proof. Now my third proof, if from a point within the circle, any point within the circle, more than two straight line can be drawn. More than two, suppose O is a point, OA drawn, OB drawn, OC drawn, more than two. Then on the circumference, that point is the center. It's a nice proof. Join AB and join BC. And suppose D is the midpoint of AB and E is the midpoint of BC. Join OD, join OE. Now OAD and ODB, what we get? OA is equal to OB by the statement of theorem, and AD by DB is by construction, and OD is the common side, hence two triangle OAOD is equal to ODB, hence two triangle are congruent, and hence ODA and ODB are right angle. We know only the center, only the perpendicular of a chord bisect, only the perpendicular of a chord bisect, only the perpendicular from the center of a chord bisect the chord, and that's why we that's why we can say O is the center. Similarly, from OBE and OEC, OB is equal to OC, B by equal to EC by construction, OD, EP, OE, OE the common sides, so two triangles are congruent, and then we say that OEB, OEC is perpendicular. Now here we see the mid, if we joint, if we know that in any straight line from center join the chord, then it divide the chord and it will be the perpendicular of the chord. Here we find OEB and OEC is perpendicular. That's why we can say that O is the center. Hence my complete proof. If from a point within the circle more than two equal straight line can be drawn to the circumference, that point is the center of the circle. Thank you so much.